For the first time in 70 years, a major NATO country is producing fighter jet engines completely outside American control. Canada is about to build advanced propulsion systems for the Saab Gripen that require no U.S. approval, no ITAR restrictions, and no Pentagon oversight. Tens of thousands of high-skilled jobs could be created in Montreal, while hundreds of aircraft across multiple continents could be supported from a single factory. The numbers are staggering. Canada alone could produce 72 engines for its own fleet, with potential for another 400-plus engines if orders from Ukraine, Colombia, Thailand, and other countries go through. For decades, every NATO fighter, F-16, F-18, F-35, depended on American engines, spare parts, software updates, and approvals, giving Washington veto power over Allied air forces. So what happens when that control is broken? What does this mean for NATO's power structure and for Canada's influence on the global stage? Keep watching as we uncover how Rolls-Royce, Saab, and Ottawa are quietly rewriting the rules of NATO air power, and why the world may not be ready for it. Swedish defense firm Saab has quietly moved from sales pitches to concrete talks with Ottawa and with Bombardier about building Gripen fighters in Canada. And those conversations are already shaping how policymakers think about the country's air force and industrial base. Saab's CEO has confirmed discussions about licensed production and a local industrial package that would tie Swedish suppliers to Canadian firms. The company has said local production could create thousands of jobs and bring long-term maintenance, upgrade, and export activity to Canadian industry. Those negotiations have drawn direct attention from Ottawa because they arrive at a moment when Canada is rethinking its F-35 decision and when the federal government is explicitly weighing the industrial benefits of any fighter choice. At the same time, Rolls-Royce's long presence in Montreal has become more than a maintenance shop. Rolls-Royce already runs major repair, overhaul, and component facilities in the city for civil aviation engines, and has built a local workforce and supply chain that can support higher-end defense work if pushed that way. That industrial footprint matters because it gives any engine program in Canada an existing base to scale from. Several trade and defense outlets are reporting that Saab and allied suppliers are exploring engine options that would avoid U.S. export controls and reduce reliance on American parts and approvals, and those options often point toward a British engine line rather than an American one. The fact that Rolls-Royce operates in Montreal makes a Canada-based line technically and politically feasible in a way it would not be if Ottawa had to create an engine capability from scratch. This is not just procurement drama. It is a test of how NATO works in practice. For decades, many Allied air forces have depended on U.S. engine makers and on U.S. export rules for spare parts, upgrades, and modifications. That dependence is real and granular. It shows up in maintenance contracts, in flight line spare parts, in software updates, and in approvals for export or for changes to weapons integrations. When a service wants to add a new sensor or integrate a weapon built outside the United States, the controls that govern those parts and the software can make or break the plan. Shifting a major part of that chain out from under U.S. control would change the bargaining power that Washington has had over Allied aviation choices for years. The idea of replacing a U.S. engine or creating a supply chain that does not rely on U.S. approvals is not theoretical. It is a clear strategic lever that countries are now talking about. To understand why this matters, start with the engine itself. The engine is the most technically demanding part of a fighter. It combines exotic alloys, precision manufacturing, high-temperature metallurgy, and tolerance to extreme stress and heat cycles. Engines take decades of industrial know-how, testing hours, and supplier networks to design and build at scale. That is why only a small group of countries and companies have the ability to deliver modern fighter engines reliably and at volume. Historically, the main sources have been the United States, Russia, Britain, France, and China. Within NATO, that reality meant most fighters and their sustainment were built around U.S. propulsion and logistics norms. When an allied country buys an American engine, buying the aircraft becomes not just a platform decision, but a long-term logistics commitment to U.S. parts and to U.S. export law. Swap that engine for one built in another NATO country, and you change the legal and practical controls that can be applied to upgrades, exports, and support. If you're enjoying this analysis, please like the video and consider subscribing. Your support allows us to keep bringing detailed global coverage. Now back to the topic. Canada's recent policy moves make that choice possible now. The new government in Ottawa has signaled a desire to hit NATO spending targets early and to diversify Canada's defense partners and supply chains. That political shift is one reason Saab's offer has traction. The company has proposed an industrial package tied to Bombardier and other Canadian suppliers, and Sweden's state and corporate actors have pressed the case during high-level visits. The timing is critical. Ottawa is not simply comparing flyaway cost and mission numbers. The government is weighing local jobs, long-term industrial capability, and whether future purchases will lock Canada into a dependency that carries political risk. That was the explicit argument used by some political leaders when they said Canada should invest in domestic capability rather than simply buy yet another off-the-shelf platform. The story has roots. Canada learned the politics of defense procurement the hard way in the 1950s with the Avro Aero program. That project was a cutting-edge interceptor that Canadian engineers built to meet domestic needs. The Aero's cancellation and the pressure to buy U.S. platforms afterward left a long memory in Ottawa and in Canadian industry. Engineers moved abroad. The domestic industry took years to recover. That historical memory shapes how policymakers think about today's choices. Buying a plane is not only about pilots and radar, it is also about whether a country can keep and grow its industrial base, and, crucially, whether it can make choices under its own rules in times of crisis. The appetite in Ottawa now favors moves that expand domestic control over critical components rather than keep the same patterns that produced dependency in the past. Historical experience and present politics are pushing in the same direction. There are concrete numbers behind the debate. Saab and some Canadian media outlets have mentioned industrial packages that could create roughly 10,000 jobs if the work is done locally. Saab itself has pointed to thousands of jobs tied to Gripen production and associated systems, while Canadian supplier networks and unions have highlighted the potential for thousands of high-skilled positions in machining, systems integration, and maintenance. On the engine side, realistic production volumes for a new fighter engine program require a base of several hundred to a few thousand units over a decade to make a dedicated line viable. That threshold is what makes the idea of combining Canadian purchases with export customers so important. A single national buy rarely justifies a standalone, long-term engine plant unless you also secure export orders or follow on domestic work. Those export prospects are exactly what Saab and some European backers are highlighting in their outreach to Ottawa. The EJ230 discussion deserves special attention because people often mix long-standing technical proposals with active production plans. The EJ230 name refers to a higher thrust variant concept tied to the EJ200 family, itself the engine for the Eurofighter Typhoon. Over the years, the idea of more powerful EJ2XX variants has circulated in trade press and in technical studies. In practice, adapting a fighter to a different core engine is a major engineering task. It affects airframe integration, weight balance, intake geometry, software, and maintenance regimes. But if a proven design like an EJ200 derivative could be adapted for a lighter fighter such as the Gripen, the resulting package would avoid reliance on U.S. engine suppliers and their export controls. That is the strategic point. The technical path is long, but the industrial and political payoff would be substantial if it can be done at scale and supported by Allied procurement commitments. Those Allied procurement commitments are not imaginary. Several countries have shown interest in Gripen or similar European fighters in recent years, and a handful of buyer names keep appearing in reporting and industry briefings. Colombia publicly ordered Gripens in recent procurement cycles. Sweden and Saab have discussed financing packages and possible sales or donations to Ukraine, and European partners have explored pooled procurement approaches. Each potential export customer alters the math. If Ottawa were to buy planes and also host engine production that would serve Ukraine, Colombia, and other smaller buyers, the total volumes could reach the threshold that justifies a dedicated production and sustainment footprint in Canada. That kind of cluster, Canadian builds plus export orders from similarly minded countries, could create a resilient supply chain outside of U.S. export controls. Those commercial realities are driving the hard selling behind the bids. What would that mean for NATO operational practice? Start small and practical. If an Allied Air Force flies jets whose engines, spares, and software are covered by rules outside U.S. law, that Air Force can approve local modifications and export certain upgrades without asking Washington for permission. That changes the bargaining table when Allied states discuss maintenance, arms transfers, or joint operations. The ability to integrate a domestically developed weapons package or a sensor from a non-U.S. vendor without running into a U.S. approval process shortens timelines and reduces political leverage. That does not remove the need for cooperation with the United States on many fronts, NORAD, intelligence sharing, logistics, but it gives allies more policy space. When a major NATO member demonstrates the ability to build and sustain modern fighters without U.S. propulsion, other members will reassess whether long-standing logistics dependencies are acceptable political risks. The result is not rupture, it is more options. That shift in options is precisely why some European firms and national governments are pushing this route now. Opponents of the idea raise practical counters. Changing engines or decentralizing sustainment can increase short-term cost, add technical risk, and stretch a supplier ecosystem that is already tight. The global market for fighter parts and qualified technicians has been strained by defense demand and by civilian aerospace production backlogs. Engine programs also require multi-year testing and certification cycles. A new or adapted engine line in Canada would need export customers who are willing to commit money upfront or guarantee follow-on orders. Critics also warn that shifting away from U.S. engines can complicate interoperability if NATO operations still rely heavily on U.S. logistics. Those are valid concerns that any realistic plan must address. Yet the counter-argument is that the status quo carries its own long-term costs. Political leverage that can be used to shape Allied decisions in ways that may not align with each ally's national interest when relations grow tense. The trade-off is between short-term technical complexity and long-term strategic independence. Both sides present clear, measurable risks. The Canada case shows how economic and strategic considerations collide. Ottawa has to weigh the sticker price of jets against the industrial package and the strategic buffer that a non-U.S. engine supply chain would provide. Jobs matter politically, and a plant that supplies engines and long-term maintenance supports a local cluster for years, not just the months of a procurement contract. That is why the talk of 3,000 to 5,000 high-skilled positions in engine production and a larger 12,000-plus employment effect across airframe and systems is important for ministers and for provincial leaders. The political calculus is not purely military. It is about regional economies, skilled workforce development, and the ability to sustain domestic production through changing political climates in partner countries. When politicians look at those numbers, they see an industrial policy with defense implications as well as immediate jobs. There is also a ripple effect in other regions. Latin America is watching. Several countries there historically bought U.S. platforms because of financing, logistic ties, or political pressure. If a different supply chain becomes credible, one that does not come with U.S. export restrictions, Latin American governments may see a viable alternative that keeps their autonomy in certain decisions. In Southeast Asia, the calculus is similar. Countries that have had to seek U.S. permission for upgrades or weapons integration will evaluate the political cost and benefit of switching to a non-U.S. centric package. In Europe, some NATO members already fly mixed fleets. Those members may welcome the chance to reduce the number of platforms that require U.S. approvals for upgrades. The spread of an alternative supply chain would be gradual, but the political and procurement ripple would be tangible. If you found this video interesting, make sure to hit that like button and leave a comment with your thoughts. Don't forget to subscribe and turn on notifications so you never miss updates on defense, technology, and global power shifts.